Good morning, everyone. Today we are going to talk about art of keeping PostgreSQL clean. But in order for me to understand the audience better, I have some warm-up questions. Hands up if you haven't heard MVCC ever. Everyone knows vacuum. Great. Anyways, for the ones who are not familiar with the topic, I will try to give some concrete examples. But today, this talk is more about a maintenance discipline. So let's say you are building, as developers, building features and applications that needs to persist data. And this place is generally the databases. So if a housekeeping or cleanup is not a discipline in your databases, one day it will show up as incident. Think of a hotel. So if you keep checking in guests all the time, but ignore housekeeping, you will not suddenly stop your business, but it will slowly become unusable. The same is true for databases. They don't fail immediately, but they accumulate the debt you create in them, and one day they will show up as incident. So here is the agenda of today. I will try to start talking about what this cleanup maintenance discipline is, and we'll cover some topics, what could really go wrong with it. There are two types of it. One of them is internal cleanup of what PostgreSQL offers to us, and the second is actually external, that actually we need to maintain our data. And there will be several techniques that I will be mentioning about based on my experience, mostly on OLTP databases. And we will end up with a decision metrics that is also correlates within mostly OLTP-like databases. But before that, 2 sentences about me. I am a database and reliability engineer, started my career at on 2012, and mostly it was enterprise databases back in the days, now open source, employed by IDN, and currently running the database reliability engineer role. Entire my career, which I really don't like one thing, is it work once mentality. So cleanup maintenance is also not a query, it is just a workflow. So we need to keep in this mind. So cleanup discipline. Here is the one core mindset I would want all developers to adapt is no resource is infinite. So disk, cache, I/O, wall bandwidth, maintenance time, everything has a limit. So even Postgres can store 32 terabytes of data, which is a huge table per relation. Maintenance capacity is not infinite. So that's what bites you first. So as part of the cleanup discipline, actually, we want databases to stay within manageable sizes, which we can call operationally healthy. Now, instinctive solution, everyone could think of that if you want to get rid of the data, delete it. But in Postgres, it's unfortunately not an erase. It is write now and clean later. Actually, vol we write, and then housekeeping works. And this housekeeping service for Postgres internally, we see it as vacuum. Therefore, our deletion strategy in the next slides, in techniques, whatever, is not actually how you delete. It's also how you do the housekeeping. Let's dive into how delete really looks like. Imagine your table is a Lego box, and each row is a Lego brick inside that box. And when you run delete, these Lego bricks are marked as not visible for future builds. Then housekeeping comes and cleans up those space, but brick space will be reusable. 2 major consequences we can see here. One of them, delete is not finished. I mean, cleanup is a workflow here. It didn't finish until the vacuum comes in and do the housekeeping. And the second is, as you see, the box size didn't shrink, which means on operating system, we didn't reclaim space back. So what is this housekeeping service? For the ones who don't know, is the actual hard worker removing the dead tuples, cleans the indexes, and makes the space reusable. And Autovacuum is just a scheduler that runs vacuum automatically based on the cluster and table thresholds. So we need to keep in mind this internal housekeeping mechanism is also competing within the production traffic. As we spoke, throughput is limited as other resources. So if the changes in the database, which we can call as churn, is bigger and greater than your cleanup capacity, then you will be creating a backlog. Generally, this will end up with bloat and unstable latency. But even this internal housekeeping service exists, there are still issues that can go wrong with it. So one of them, first, is long transaction poison. Vacuum can only remove the dead versions when no other active transactions might still need them. So one long-running transaction, a reporting query, or idle in transaction state can cause this old snapshot alive, which prevents the housekeeping. This creates one of the most confusing incidents, actually. You would write a delete job, the delete job finishes, but bloat keeps increasing. Vacuum seems running, but it's not cleaning anything. So unstable latency is just caused by long-running transaction. We can think of this like a hotel analogy that if you keep the do not disturb sign on the door for a month, then the room will be a mess, then the performance will degrade. Second is visibility map regression. But what is visibility map, actually? Visibility map is a file that is based in the base data directory of Postgres, nearby the data files and free space map. It is actually holding 2 bits of data, all visible and all frozen. It's like you can think of like a green sticker that is actually in the hotel room that can allow this room is clean. There's nothing to check for heap access, for index scans. But if a delete happens, this green sticker is being removed. So next run, housekeeping needs to enter the room and check it actually. So this is what we call as visibility map regression. You see, green sticker either has all visible or all visible plus all frozen. There will be less work for housekeeping to be done. And if it is not visible, housekeeping has to go and do the work again. So index-only scans are heavily relied on visibility map. And mostly update and delete is actually clearing out these green stickers. So when we first run vacuum, we are actually updating this and we are setting these bits to all visible true or all frozen true. And meanwhile, before the first vacuum runs, if we need to reach to these data over index scans, the performance might degrade because we actually don't know if the index access is sufficient. So the heap fetches has to be done. Index-only scan here performing worse than before. So what can go more wrong? One day, a developer approaches and tells me that I have a query that works pretty fine on primary, same plan, looks like same plan, but on replica, it is much worse. The reason is, on primary, things may look okay because of the warm cache and the high churn. And one more thing, which is very tricky, even this is in the source code of B3, that if you have some known dead items in the index, there is a LP dead flag is being set. So in the reception of the hotel, this page this index tuple is already marked as that. So within the index scan, you don't really need to go into that tuple. But for replica, unfortunately, this access is being set as ignore kill tuples false. So for replica, it is working way differently. There is a hacker discussion about this, but this has been paused for a while in the past. That might be worked in the later. Actually, I am also interested in this. Other thing is, as we spoke, disk doesn't shrink. But there are things that we might need to do, reorganizing the relation. The vacuum, normal vacuum, doesn't really shrink anything, mostly if page truncation is not on the table. But basically, we need to reorganize this object, and this is generally within vacuum full or extensions that can do the job for us. And for indexes, we can use reindex concurrently to reclaim the space back at the OS level. All these can go wrong without delete statement as well, because update is also a delete. Update typically creates a new version and marks the old ones same as unusable for the future builds. So high update churn also produce garbage continuously. And vacuum is playing the same role, is to just reclaim this space back and make it reusable for future builds, but still nothing on the operating system level. But talking about these update and deletes, like this shouldn't sound like this is very harmful, because we are running databases. Update and deletes, there will be always there. And what if we need to pick a method? Here, I have listed different techniques how to do it on production. First 5 is mostly focusing on DML-based, what we can programmatically do, and last 2 is actually DDL, which we get rid of the objects for good. Okay, see, we all know this. This is okay when we are working within a small volume of data and if the selection is predictable. And this is risky if we keep touching large portion of the data, which might cause wall spike, and we are creating a depth for vacuum. And many indexes within the delete will always create a heavy index cleanup work that vacuum needs to work later on heavily. It looks like this. So the rule is simple. So if it is not big, use this. If it is, it should be a job, batching, pacing and stopping and monitoring. So this is usually the best option if you have an ordered key, batch delete, and the primary keys actually can help us. And if you have a monotonic-ish like primary key, you can use this method. And if you are doing the small commits and you can predict wall generation, and you can control the replication based on this. And this is risky if your locality key and key order doesn't really match, because you need to touch many heap pages and per batch, and actually this might be a killer. But low correlation doesn't mean that table is broken. It means primary key order actually not physically matching the placement. So this can, like this situation can populate over the time within the bloating and etc. One analogy about this physical key locality is, it's like still the hotel room analogy. The rooms that we are going to clean are at the same hallway, or are they distributed to different floors? So this can cause more random IO patterns. What we need to do, we need to keep the batches small, and short sleep. This is also something that we need to keep in mind because this can also cause some incidents which might impact the replica heavily. One day we have written a bad job that the delete was very performant, but since there was no sleep between them, we still created the backlog behind. So replica a little bit suffered. This can cause another incident. But if you don't have a clean key order, next thing that you can use is CTE batching. CTE is a physical location of this specific tuple, an invisible column in Postgres. So in order to fetch the data that you are not aware that there is no ordered key, no primary key, but you still want to delete some stuff, you can use CTE. This is okay if you still want to limit per transaction, but you need to control it over the traffic. This is risky when your prediction is weak and you need to maybe use in very good indexing over the time, because at the end I will be showing you a repository that I have done different tests within different techniques that CTE is falling a little bit behind comparing to the others. And as we say, like, we need to make it cheap, which we need to index it. Limit small within the CTE also something we need to keep in mind. This is an example how it should really look like. First, we are defining our batch size, then we are reaching out this physical location. This CTE is actually the block number and line pointer and offset number of this is a list. Then creating a common table expression here, then deleting from the main table. Now, sometimes people reach to cursors. This is per business logic. You need to fetch data. You first access the data set, then you fetch from this data set, and you work on this fetched numbers. This is also risky that within the cursors, if it is not planned, okay, you can create long-running transactions again, and vacuum can be blocked. If you're not running this on server side, many round trips is required, because once you fetch, it calculates it again and fetches it into the memory. So we need to commit frequently to avoid long-lived cursors again. So if the target data is not easy to reach, there's very big complex of joins that you need to collect the data, then stage keys might be your solution. This is pretty underestimated, because creating an unlock table or temp table and loading data to this staging area, then using the primary key or whatever key you have, you can really paste the things up. So this is more like compute once and delete safely. You can, in this way, also enable the parallel workers. This method is generally used by the developers when they want to fix some portion of data, when they want to update it. This is risky if the stage data changes, because you need to get rid of the data quickly. This is just a fix. And staging doesn't really remove the foreign key cost. The same applies to other batching techniques. For example, if you are using a cascading foreign keys, you are thinking that you are deleting one row from the parent, but it can just go to the child and have to delete maybe n number of rows. So we need to be careful. The default foreign key option is not cascading, so Postgres basically will not allow you to delete, and so you need to control it by yourself. First delete from the child, than from the parent. So this is the golden method if you really use. If you have partitioning, there is a completely different level. So instead of deleting rows, you are just getting rid of the whole partition. But partition detach and drop is actually attractive because you think like instead of deleting millions of rows, you're just dropping it for good and it's instant. But although it sounds like this the safest option, there are things with it. So your data retention has to align within the partition boundaries, obviously. And seems like fastest cleanup, that's true. It's actually only few records in the WOL file and minimal vacuum that afterwards, from the Postgres perspective, of course, because you are escalating things to the operating system and the block level. But can detach and drop cause deadlock? Yes. It is actually risky if you detach multiple partitions in one transaction while running a concurrent churn environment, let's say, a lot of changes and a lot of concurrencies in the database, then this is very big risk. So you need to detach in one transaction. So foreign key and triggers are still there and they can amplify the lock behavior. So detach and drop, they can cause deadlocks. But the thing is, DDL actually takes the lock on the parent and partition structures. If your DMLs and foreign key checks are the different order, then it is risky. So be careful to detach everything in one transaction separately. Use concurrently whenever you can. Detach partition concurrently is available after version 14. So it is good to keep in mind that detach concurrently can be run. Basically, what concurrently does, it waits for the current long transactions, I mean active snapshots, let's say in this way, and then it will try to get the lock and then do the job. Lock and statement timeout, mostly lock. If you cannot acquire a lock, just wait, then retry again, then wait, retry again until you get the lock. The concurrently will already help us in this way. One more thing within partition detach and drop, use this DDL-based cleanups during the low write window. If your table is not partitioned, but you still want to get rid of the data, or your relation gets too much, but your business says like, I don't need this data anymore, you can rewrite and snap. So this is actually moving the necessary data to a new relation, then getting rid of the old one. This is risky because it might need an extra space if you're really in danger. This needs to be carefully taught. And while you are actually dropping something, you need to really be careful if the access of this relation has to be stopped. So this is actually already another workflow that we need to think like a migration. We need to validate the data, then swap it, then verify. So based on all these techniques, I have created some feature metrics that delete statement versus DDL-based cleanup and several features that most of the RDBMS systems has. So the transaction lock for the delete statement is row exclusive, while the DDL-based is actually access exclusive, which is the blocking. Dirty buffers for delete is creating high, while DDL is near zero. And wall usage on delete might be massive. You need to control, but everything, every delete record needs to be written to the wall files. But partition, drop, or DDL-based thing is actually few records in wall. Disk I/O can create random high I/O and within the delete, while within the DDL it's low. As I say, we escalated things to operating system and block level. There are other things that might make this disk I/O very catastrophic for us for DDL, but that's a different story. Cleanup within the delete can be slow while metadata change is instant. Bloat leaves that tuples, the holes in the table, while DDL-based creates a fresh and compact file. More and more, the referential integrity for delete, we need to think about the child first. And we need to go from the child to the parent. While within the DDL, it can be very lock heavy within the foreign keys. So mostly DDL is how you manage the locks in your system. So as promised, here is the decision matrix that we can think of. If you can use table partitioning, do the detach and drop to get rid of the data. And if not, maybe you can swap it within the portion that you need. If not, maybe you have a monotonic key, but you don't have a monotonic key, you need to use the physical location of this tuple, which we can call CTID. If the IDs are known, but it can be created within the complex joins, you can use stage keys. You can create the temp or unlocked or staging area for these keys, then join with your main table to remove them within batch, using batches, of course. If you have the key set batching, which corresponds to IDs are known, there are two methods. Either you want to work within the fetched versions on memory, which corresponds to cursor, or key set loop that we have discussed in the beginning using primary keys. A recap: cleanup and maintenance should be a discipline. So no one is going to clean the things up for us, and resources are not infinite. Any project that you work on, data archiving, data tiering, however you call, everything is actually a migration. And if you need to keep the data, maybe you need to keep it in a less expensive storage. So move it from your main system to a secondary system, but that still requires a cleanup from the main system. So there are boundaries within the DDL and DML-based cleanups. You need to select the best technique based on your workloads. One workload might be better than the other one in terms of using a DDL, while DML can be the only solution that you cannot really work on. Another important thing, we need to know, or you need to know, your workload based on making the right decision. I have added this QR code. Unfortunately, it has summoned at the beginning, but with this visibility map regression tests and batch techniques comparison, I've done some small POC and added them to the GitHub. I was faster than expected, but thank you. Now it's time for questions.
Okay. Okay. So thank you for the talk. Do we have any questions? I think we have plenty of room for questions. And in my experience, problems with vacuum and cleanup are quite common. So I would expect at least some questions. There are no questions so far. Okay, there is a question over there.
Hi. In that example with CTID, the fetched result, the CTE, was sorted by timestamp. Isn't it better to sort it by CTID itself? So it's deleted sequentially how it's stored on the disk?
True, this was just an example. Mostly in real-world scenarios, this example might not fit, but the main idea here, if you cannot reach the data using a simple query, and if you cannot fetch this prediction, then you need to use the CTID. It's the actual physical location of that tuple.
Okay, any more questions? So, okay.
Yeah, hello. It's more a remark and then a question. I'm using CTID deletion also on a partitioned table, but one important thing is to keep predicate CTID together with table OID because that identifies the table within which the CTID identifies the row. But my question here is how it perform compared to index-driven deletion.
You mean the different comparison between the different techniques?
No. Particularly the CTID deletion. I mean, this
okay.
one example.
So let's say in this example, if your filtering area is indexed, selecting the CTID needs to still fetch the row from the tuple. So it is less performant to the other techniques, but you need to use for sure index scan and index access path using CTID. Otherwise, it's a killer.
Yeah, I understand, but so the first part is index-driven, the one within the CTE of the query, but the second part, does it perform well when using CTID to identify?
I see. So that's the reason I have added this small tests within different methods. You will see within different methods how CTID really behaves is actually taking more CPU time comparing to the others. At the end, you will be seeing it in the repo.
Any more questions? Oh, sorry.
My question is about a partition table where we have a big partition, like the one partition itself is very huge. It takes a lot of time to vacuum it, which can block the table from updates. And now we are trying to use PG repack. So do you have any suggestions on that, like how to go about? Because at the moment we are not doing vacuuming at all, so the table is really bloated because of that.
Yeah, I might have one suggestion if your partitions are going to somewhere that's unmanageable. Maybe you might need to repartition that big portion. Maybe you need to create a new strategy and you need to migrate the data. So detaching and attaching is very flexible, and based on your workload, you can do this programmatically. How to rewrite a big partition into a smaller one, I have written a blog about it. Maybe after the talk we can discuss about it, because big partitions are also mess during the vacuum, after switchovers. Big objects are always mess.
Okay, any more questions? So I guess no. So thank you for the talk. I assume you will be here till the end of the day. So if anyone happens to have a question later, feel free to approach Cagri and
Sure.
ask questions later. So thank you.
Thank you.